guys, welcome to Speedlabs. Today we will see the forces in nature and different types of forces like contact forces and non-contact forces. Okay, let us first understand what is the actual meaning of force. Okay, just I am taking one example. Here you can see a boy who is trying to push this block of mass, let's say m. Okay, consider the mass of the block is m. The boy is trying to push the block in the right hand side. Similarly, on the other example, we can see the boy is trying to pull this box of mass m in left side direction. So what is force? Force is actually a push or a pull. Okay, force is basically a push or pull. Okay, so there are the different types of effects which force can actually cause. Okay, so let me give you some of example. Let's say I have a block. Let's say I have a block of this mass m, which is on the ground. Okay, let us say it is moving with some velocity v in right hand side direction, and if I had applied the force vertically upward, okay, so what will be the final velocity of this block m? So this block m will get the velocity in upward direction, as well as previously it is moving in the right hand side direction. So what actually force can do? Force can also change the direction of an object. Similarly, for example, I have this a band, let's say I have this a rod of length L, for example, and if I just applied force on this right hand side, so what will be the effect of the force? This force can increase the length of this rod. Yes. So what the force can cause? Force can change the length, as well as I can say it can change the dimension of the body. It can change the direction as well. Okay, so basically force can also like say if you have a rubber like structure and if you applied force in various directions, so force can also change the shape and size of the object. Okay, so force, have you understand? Force is nothing, it is just a push or pull. It is referred as a push or pull. We can apply it and we can change the direction of an object, moving object. We can change the dimension of the object. We can change the shape. We can change the size of an object. Okay. So particularly there are two different types of forces in nature we can see. Okay. So the different types of forces are the first one is non-contact forces and second one is contact forces. First we will see what are the non-contact forces. Okay. So basically the non-contact forces are the types of forces in which the contact between the two bodies is not necessary. It is not required. I will just give you example. See, if I have a charge, let's say Q1, okay, this is the charge Q1. Consider this charge as a positive charge, and similarly at some distance, let's say this is the distance will be R. I have another charge, let's say Q2. This is also a positive charge. Okay, so as you know, then when the charge are kept in a contact contact with each other at a certain distance, let's say R, they exert force on each other. Depends on the nature of the charge. If the two charges are positive in nature, they repel each other. If the two charges are unlike in nature, like one is positive, another one is negative, then they will attract each other. So in this case, I have taken particularly both the charges are positive. So this charge will apply force on this Q2 in this direction. Okay, so I will write this as F21. Similarly, this charge Q2 will apply force on this Q1 in left hand side direction. Okay, wait. Okay, so the Q2 charge will also apply some force on this Q1 in this direction. Okay, okay, in this direction, and consider this as F12. Okay, the important point here, you will see this F12 is always equal to minus of F21. So basically, what are the non-contact forces? Basically, non-contact forces do not require any contact and they exert force at the same time. Like here Q2 is applying force on Q1, but there is no contact in between them. Understand? So this types of forces, like particularly this type of force is an electrostatic force which is exerted between the two charges. Understand? Okay. Similarly, I have another example. There are many examples we can say. There are gravitational force also. Like what is gravitational force? If I have a mass m1 and I have a mass m2 and they are kept at certain distance r, then these masses will automatically attract each other. This is an example of gravitational force, and the value of this force is given by F is equal to gravitational constant G m1 m2 upon square of distance between them. This is the force of attraction between the two charges. Here we can see there is no contact between the two charges. Understand? There is no contact between the two charges, and these masses will attract each other automatically. So basically non-contact forces do not require any contact and they exert force on each other. Understand? Like magnetic force, you all have played with the magnets. You just came a magnet together and they started repelling, or this either they started attracting. So basically without the contact, force exerts. So these types of forces are basically called non-contact forces. Okay, okay, very good. Electrical force, gravitational force and magnetic force, all are the examples of this non-contact forces. Understand? Okay. So basically electrostatic force, as I have discussed here, what is electrostatic force? It is the force between the two charges kept at a certain distance, and I will just clear you. The magnitude of this electrostatic force Fe is equal to basically 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This is basically the formula for electrostatic forces. Here 1 upon 4 pi epsilon naught is an electric constant whose value is 9 into 10 raised to power 9. Understand? And what is its SI unit? It will be Newton meter square per Coulomb square. Understand? Okay. It is represented by a constant. Okay. So basically these all are the examples of non-contact forces. Okay. As I have understand, I have just okay. Just the other types of forces are the contact forces. Now these types of forces okay. So contact forces, the other types of forces we will understand is contact forces. Now contact forces are the forces in which contact must be required. There is a contact, then only the force can exert. Understand? Like just see an example. If I have a rough surface, let's say I have a rough surface in which I have kept a block of mass m, and suppose this block is moving with velocity v here in this direction, right hand direction. So automatically this surface will start exerting some force in the opposite direction as the direction of motion, and this force is particularly known as frictional force. Understand? Frictional force. This is a frictional force. Understand? This is frictional force. So there are many types of forces in which contact is required. On the other hand, if I have just taken like this here I have a ground like this, and the block mass is here, there is no contact between them, then frictional force cannot be acted like this, because frictional force is a contact force. It requires a contact between the two surfaces. Understand? On the other hand, see this boy. He's pulling a dumbbell to make his bicep. Okay, so there is a contact between his dumbbell and his hand. Understand? Then only this contact comes and the force is applied on because of that dumbbell. Understand? Similarly, like this, here you have a box which is kept on a table. Understand? And there is a contact between them. So basically contact forces are the forces in which contact required between the two bodies. Understand? Okay. Now the normal force is also example of contact force. Here the block let's say of mass m is kept on a table. Okay, so mg is a gravitational force which is acted by the mother earth, okay, in downward direction. Similarly, according to Newton's third law, okay, there is a reaction pair that automatically occurs when action acts on a body, and this normal reaction is acted by the table on this block, and this is just opposite to mg. So this is basically a contact force, normal reaction. Okay, similarly, if I have taken one example, see this example. Okay, I have, let's say, I have a surface like this, and I have kept a rod like this. Understand this? Okay, see the example. I have taken a bucket, let's say, in which I have kept a rod. Okay, I have taken this rod, and this is like this. Okay, this rod have a mass m, let's say. This rod have a mass m. Okay, so as you can see, at this particular point there is a contact. So this surface, like this surface, I will consider this is S1. Okay, this surface S1 will surprise this rod with acting a force in this direction, like this direction, and this direction is perpendicular to this rod. Understand? So this will be our normal reaction. Normal reaction always acts perpendicular to the surface. For example, here is a contact. There is a contact between this surface, this bucket, and this rod. So normal reaction will also act like this is N dash. Okay, so these are the examples of normal reaction. Okay, now similarly, let us take one more example. Like I have this block of mass, let's say m1. Understand? And I have another block which is kept on above this of mass m2. Okay, so there will be a normal reaction obviously between these two masses, like this. This is basically N dash. This is the normal reaction which is acted by this mass m1 to the mass m2. Similarly, an reaction pair occurs here, and m2 will obviously act between these two bodies, and this will act as a normal reaction, like this is N double dash. Understand? So basically this is the normal reaction which always acts perpendicular to the surface, and it is a contact force. Understand? Okay. Okay, so we have understood what are the contact forces and what are the non-contact forces. So okay,